Imagine you're traveling through space when suddenly you find yourself approaching one of the most mysterious objects in the universe, a black hole. But what would happen if you didn't just look at it from a distance? What if you actually fell into one? Before we begin, let's clear up a common misconception. A black hole isn't a giant cosmic vacuum cleaner sucking everything around it. From far away, it behaves much like any other massive object. The real danger begins when you get too close. As you approach, the gravitational force becomes stronger and stronger, reaching levels that are almost impossible to imagine. Eventually, you reach a boundary called the event horizon. This is the point of no return. Once you cross it, escaping becomes impossible. Surprisingly, crossing the event horizon might feel completely normal. There may be no explosion, no sudden impact, and no warning sign telling you that you've crossed it. However, gravity is not equally strong everywhere. The force pulling on your feet becomes much stronger than the force pulling on your head. This difference in gravity creates an effect known as spaghettification. Yes, that's the actual scientific term. Your body would begin stretching longer and longer. Every muscle, every bone, and every organ would be pulled apart by the extreme gravitational forces. Eventually, the structure of your body would no longer be recognizable. Matter itself would be stretched beyond anything a human could survive. But here's where things become truly strange. What you experience and what an outside observer sees are completely different. To someone watching from a safe distance, your movement would appear to slow down dramatically as you approach the black hole. That's because time itself begins to behave differently near extreme gravity. The closer you get, the slower your clock appears to run. This phenomenon is called time dilation, and it has been confirmed by Einstein's theory of relativity. While only minutes may pass for you, years, decades, or even centuries could pass for people far away from the black hole. If it were somehow possible to return, you might discover that the entire world you once knew had changed forever. That's because black holes don't just affect time. They also bend the very fabric of space itself. Imagine placing a heavy bowling ball on a stretched sheet. The sheet bends downward. In a similar way, massive objects bend spacetime. Near a black hole, this distortion becomes so extreme that light itself begins to curve around it. You would see stars appearing in strange places and light wrapping around the black hole in impossible-looking patterns. The universe around you would start looking less like reality and more like a surreal science fiction movie. Surprisingly, not all black holes are equally deadly. Size actually matters in a very unexpected way. Supermassive black holes may allow you to cross the event horizon before experiencing severe stretching effects. But regardless of size, every black hole hides a mysterious center known as the singularity. The singularity is where our current understanding of physics completely breaks down. Scientists can describe what happens around a black hole, but what happens inside remains one of the greatest mysteries in science. At the singularity, gravity may become infinitely strong, causing space and time to lose their familiar meaning. Some theories suggest that black holes could connect distant parts of the universe through structures called wormholes. Others speculate that they might even lead to entirely different universes. For now, these ideas remain purely theoretical. Despite decades of research, no evidence has yet confirmed that such journeys are actually possible. What we do know is that black holes represent the limits of human knowledge. They challenge our understanding of time, gravity, and reality itself.
But let's imagine somehow you survive longer than expected. You continue falling deeper and deeper into the black hole. The outside universe begins to look increasingly strange, as if reality itself is being stretched and distorted around you. The stars that once looked familiar no longer appear as points of light. Instead, they stretch into glowing arcs and rings, warped by the extreme curvature of space-time surrounding the black hole. If you could still look outward, something extraordinary might happen. Time in the outside universe could appear to speed up dramatically before your eyes. Entire generations of humanity might rise and fall in what feels like only a short period to you. Civilizations could be born, flourish, and disappear while you continue your descent. You might witness the distant future of Earth itself. Oceans changing, continents shifting, and perhaps even the eventual end of our species. Continue watching long enough, and you could see the sun exhaust its fuel, expand into a red giant, and transform into a stellar remnant. Beyond that, entire galaxies may collide and merge. Massive structures that normally evolve over billions of years could seem to unfold before you like scenes in a movie. Yet everything depends on one crucial detail: the type of black hole you're falling into. Not all black holes behave exactly the same way. A relatively small black hole would be incredibly violent. The tidal forces near it are so powerful that you would likely be torn apart long before reaching the event horizon. A supermassive black hole, however, is different. Because of its enormous size, the gravitational gradient near the horizon can be much gentler, at least initially. This means you could cross the event horizon without immediately noticing anything unusual. The true danger would still be ahead of you, and now we arrive at one of the most fascinating ideas in theoretical physics. Could a black hole actually be a doorway rather than a dead end? Some mathematical models suggest the possibility of wormholes, hypothetical tunnels connecting distant regions of space and time. In science fiction, wormholes allow travelers to cross vast cosmic distances almost instantly. They are often portrayed as shortcuts through the universe. Some even speculate that wormholes could connect entirely different universes, creating bridges between realities that would otherwise remain forever separated. The problem is that no one has ever observed a wormhole. At the moment, they remain mathematical possibilities rather than confirmed physical objects. Another mystery concerns information itself. If every object that falls into a black hole disappears, what happens to the information describing that object? This question became one of the greatest puzzles in modern physics, known as the black hole information paradox. Physicist Stephen Hawking proposed that black holes slowly emit radiation and eventually evaporate over unimaginable periods of time. But whether information survives this process remains an open question. So, what would happen if a human passed through a black hole? The most likely answer is that the journey would end in destruction. Your body would be stretched, crushed, and ultimately erased by forces beyond anything found elsewhere in the universe. Yet beyond that point, certainty disappears. Black holes stand at the edge of our scientific understanding, where the known laws of physics collide with the unknown. They are not just cosmic objects. They are gateways to some of the deepest questions humanity has ever asked. And perhaps one day, somewhere in the future, we will finally discover what truly lies beyond the darkness.